In this 2004 AMC 12 problem, a sequence of three real numbers forms an arithmetic progression with the first term being 9. When 2 is added to the second term and 20 added to the third term, the three resulting numbers form a geometric sequence. What is the smallest value for the third term in the geometric progression? Well, first of all, since we need to find the third term, let's make that variable be x and have a2 be equal to x plus 9 divided by 2, making it an arithmetic sequence. Now, let's add 2 and 20 to the second and third term. Since the first term, since you don't add anything to the first term, that just stays the same, it's 9. Add 2 to the second term and you'll get x plus square root 13 divided by 2 and x plus 20. Now in the last video, we learned this about geometric sequences, that the square of the second term is equal to the product of the third term and the first term. So that means, let's put that in, that x plus 13 divided by 2 squared is equal to 9 times x plus 20. Now, if we divide both sides by 4 to get rid of the 2 on the denominator, then we'll get x plus 13 squared is equal to 36 times x plus 20. By expanding these, we get that x squared plus 26x plus 169 is equal to 36x plus 720. And we put this on one side, we'll get x squared minus 10x minus 501 is equal to 0. But by factoring out 551, we realize that this is also equal to x minus 29 times x plus 19. Oops, ran a room there. Now, since we are looking for the smallest term in the geometric sequence, that means that x has to be as small as possible. So that means that x is equal to minus 19. By putting that into here, then we'll get that a3 is equal to minus 19 plus 20, which is equal to 1, which is going to be A. And there you go. In this 2003 AIME problem, there's an increasing sequence of 4 positive integers, with the first 3 terms being an arithmetic progression, and the last 3 terms being a geometric progression. With the first and fourth term differ by 30, we have to find the sum of the 4 terms. So first of all, let's let a1 equal to a minus d, a2 equal a, and a3 equal to a plus d, with the difference being d. Now, since we have values to a2 and a3, we can have the value of a4, since the last 3 terms of this sequence is a geometric progression. What that means is that a4 is equal to this over here, because a4 times a2 is equal to the square of a3, which you can tell is true. So let's use the last fact in this problem, that the first and fourth terms differ by 30. Since it's an increasing sequence, obviously it is also just a4 is equal to a1 plus 30, so which is this over here. Now, by multiplying both sides by a, we get a plus d squared is equal to a squared minus ad plus 3a. By expanding the left side, we get a squared plus 2ad plus d squared is equal to the same thing that's on the right side because we haven't changed it. Now, as you can see here, we have a squared on both sides. So let's just cancel them. And what we're going to do now is that we're going to make a the variable of the equation. What that means is that we're going to group all the things with a, these over here, onto one side of the equation and everything else on the other side. The reason that we're going to do this with a instead of d is because d has a second degree over here, whereas a in all these doesn't have, only goes to the first degree. So let's do that. Okay, so that means that 3, oops, not 3 looks weird, 3ad minus 3a is equal to minus d squared. So now if we take a out, that means we get a 3d minus 10 is equal to the same thing. And when we both divide, oh sorry, this is a 3. When we divide both sides by 3d minus 30, we get that d squared divided by 3d, oops, sorry, 30 minus 3d. What I did here is get rid of the minus by multiplying it to 3d minus 30, in case you were confused about that. Now, we can obviously tell, since a is an integer, d has to be a multiple of 3. So let's write that down. D is equal to 0 mod 3, which is also the same thing as d being a multiple of 3. Now, since d and a are both greater than 0 because it's an increasing sequence of 4 positive integers, this makes it so that d has to be smaller than 10, because if we put 10 and d as being 10 and this over here, then we're going to get 100 divided by 0, which we don't exactly know the value of. Plus, if you put d as anything greater than 10, the a is going to be negative, which obviously we can't have because it's a sequence of positive integers. So yeah, d is smaller than 10. What we did just now is called casework and bounding, where we found values of d where it's in a certain frame. This over here, all is casework is bounding. Now we're going to do the casework part of it. So since d is smaller than 0, is greater than 0, d is smaller than 10, and d is equal to 0 mod 3, then we only have 3 choices left. D is equal to either equal to 3, 6, or 9. These are the only numbers that fit in these circumstances. So now we're just going to do the casework. So by plugging these numbers into this over here, we can get values of a, and we can check which of them work, which of them don't work, and find our answer. So if we put d is equal to 3, then we're going to get that a is equal to 3 divided by 7. So that's not exactly an integer, so that one doesn't work. So now let's do d equals to 6. When we put that in, we get that, a is equal to 3. Now, this looks okay at first because they're both integers, right? But if we put these values into a1 over here, then we get a1 is equal to 3 minus 6, which is not exactly a positive integer. So that one doesn't work either. So guess the value of d. Yeah, it's 9. But we're going to prove it first. So let's put that in to here. So that means that a is equal to 27, which is a is greater than d, plus it's an integer. So yay, this one actually works. So now let's plug that into this over here, because we want to find the sum of the 4 terms. So that means that these terms are as follows. a1 is equal to 18, A2 is equal to 27, A3 is 36, and A4 is 48. Now by adding these all together, we're going to get our answer, 129. And there you go. That's our answer. That's how you do the problem.